In the last video, we showed that the squared error between some line y equals mx plus b, and each of these points, each of these n data points, is this expression right over here. In this video, I'm really just going to algebraically manipulate this expression so it's ready for the calculus stage, so that we can actually optimize, we can actually find the m and b values that minimize this value right over here. So this is just going to be a ton of algebraic manipulation, but I'll try to color code it well so we don't get lost in the math. So let me just rewrite this expression over here. So this whole video is just going to be rewriting this over and over again, just simplifying it a bit with algebra. So this first term right over here, y1 minus mx1 plus b squared, that's going to be, and we could write this is all going to be the squared error of the line. So this first term over here, I'll keep it in blue, is going to be, if we just expand it, y1 squared minus 2 times y1 times mx1 plus b plus mx1 plus b squared. All I did is I just squared this binomial right here. You can imagine this, if this was a minus b, it would be a squared minus 2ab plus b squared. That's all I did. Now I'll just have to do that for each of the terms. And each term is only different by the x and the y coordinates right over here. So the next term, and I'll write it, I'll go down so that we can kind of combine like terms. So this term over here squared is going to be y2 squared minus 2 times y2 times mx2 plus b plus mx2 plus b squared. Same exact thing up here, except now it was with x2 and y2 as opposed to x1 and y1. And then we're just going to keep doing that n times. We're just going to keep doing it n times. So we're going to do it for the third, x3, y3, keep going all the way until we get to this nth term over here. And this nth term over here, when we square it, is going to be yn squared minus 2yn times mxn plus b plus mxn plus b squared. Now, the next thing I want to do is actually expand these out a little bit more. Let's expand these out a little more. So let's actually scroll down. So this whole expression, I'm just going to rewrite it, is the same thing as, and remember, this is just a squared error of the line. So let me rewrite this top line over here. This top line over here is y1 squared. And then I'm going to distribute this to y1. So this is going to be minus 2y1 mx1, that's just that times that, minus 2y1b, and then plus, and now let's expand mx1 plus b squared. So that's going to be m squared x1 squared plus 2 times mx1 times b plus b squared. All I did, if this was a plus b squared, this is a squared plus 2ab plus b squared. And we're just going to do that for each of these terms, or for each of these colors, I guess you could say. So now let's move to the second term. So plus, it's going to be the same thing, but instead of y1s and x1s, it's going to be y2s and x2s. So it is y2 squared minus 2y2 mx2 minus 2y2b plus m squared x2 squared plus 2 times mx2b plus b squared. And we're going to keep doing this all the way until we get the nth term. All the way until we get to the nth, I guess, color, we should say. So this is going to be yn squared minus 2yn, minus 2yn mxn. You don't even have to think. You just have to kind of substitute these with n's now. We could actually look at this, but it's going to be the exact same thing. mxn minus 2ynb plus m squared xn squared plus 2mxnb plus b squared. So once again, this is just the squared error of that line with n points, between those n points and the line y equals mx plus b. So let's see if we can simplify this somehow. And to do that, to do that, what I'm going to do is I'm going to kind of try to add up a bunch of these terms here. So if I were to add up all of these terms right here, if I were to add up this column right over there, what do I get? Well, it's going to be y1 squared plus y2 squared plus y all the way to yn squared. That's those terms right over there. So I'm going to have that, and then I'm going to have minus. You have this common 2m amongst all of these terms over here. So let me write that down. So then you have this 2m here, 2m here, 2m here. So then you're going to have, let me put parentheses around here. So you have these terms all added up. Then you have minus 2m times all of these terms. So you have, actually, let me color code it just so you see what we're doing. I want to be very careful with this math so that nothing seems too confusing. Although this is really just algebraic manipulation. So if I add all of these up, I get y1 squared plus y2 squared all the way to yn squared. I'll put some parentheses around that. And then to that, we have these common terms. We have this minus 2m. So we can distribute those out. And so this actually, I should actually write it like this. So we have a minus 2m times, once we distribute it out, up here we're just going to be left with a y1, x1. Maybe I could call it an x1, y1. x1, y1. That's that over there with the 2m factored out. Plus x2, let me do that in another color. I want to make this easy to read. Plus x2, y2 plus xn, yn plus x. And well, we're going to keep adding up. We're going to do this n times, all the way to plus xn, yn. This last term over here, yn, xn, same thing. So that's the sum. So this stuff over here, let me just in a new color. The sum of all of this stuff right over here is the same thing as this term right over here. And then we have to sum this right over here. And you see again, we can factor out here a minus 2b out of all of these terms. So we have minus 2b times y1 plus y2 plus all the way to yn. All the way to yn. So this business, so these terms right over here, when you add them up, give you these terms, or this term right over there. And let's just keep going. And then in the next video, we're probably going to run out of time in this one. In the next video, I'll simplify this more, and it'll actually clean up the algebra a good bit. So then the next term, what is this going to be? Same drill. We can factor out an m squared. So we have m squared times x1 squared plus x2 squared plus all the way, actually I want to color code them. At least I forgot to color code these over here. Plus x2 squared plus all the way to xn squared. Plus all the way to xn squared. Let me color code these. This was a yn squared, and this over here was a y2 squared. So this is exactly this. So we've written, so in this last step we just did, this thing over here is this thing right over here. And of course we have to add it, so I'll put a plus out front. We're almost done with this stage of the simplification. So over here we have a common 2mb. So let's put a plus 2mb times, once again, x1 plus x2 plus all the way to xn. All the way to xn. So this term right over here, is the exact same thing as this term over here. And then finally we have a b squared. in each of these. And how many of these b squareds do we have? Well, we have n of these lines, right? This is the first line, second line, then a bunch, all the way to the nth line. So we have b squared added to itself n times. So this right over here is just b squared n times. So we'll just write that as plus n times b squared. Now it doesn't look like, let me remind ourselves what this is all about. This is all just algebraic manipulation of the squared error between those endpoints, and the line y equals mx plus b. It doesn't look like I've simplified it much, and I'm going to stop in this video right now. In the next video, we're just going to take off right here and try to simplify this thing.